Okay, here we go. We're gonna hope it's not just my voice. So, continuation of 1B.8. We were talking about creating our sign charts, our sign graphs, and determining where things are. So on 4B, we had gotten to the point where we figured everything out. We subtracted our 2, created 1, and now we're looking at 7 minus x over x minus 3. From 7 minus x over x minus 3, we were able to identify our x-intercept and our vertical asymptote. Agreed? All right. Now that we have those lined up, then we're going to identify what's positive and what's negative, right? So starting to the left of 3, I can plug in 0. I'm going to plug in 0 in case you were wondering. Why? Because I told you, anytime I can use 0, guess what I'm going to do? Use 0. So when I plug 0 into this, that just leaves me with 7 over negative 3. So the output is going to be negative. Agree? All right. So we have a negative output here. All right. Now I got to choose a value between 3 and 7. What value between 3 and 7 would you like to use? 5. I heard a 5. That's instead 4. So 7 minus 5 gives us positive 2. 7 minus 5 gives us positive 2. 5 minus 3 gives us positive 2. So therefore, our output is 1, which is positive. All right, now we're going to choose a value to the left of 7. Choosing a value to the left of 7. Let's just do 8. 7 minus 8 is negative 1. 8 minus 3 is 5. So we have a negative over a positive, which makes a negative. So we're looking for when is this function less than or equal to 0, which means that we need it to be negative. Where is the function negative at? There we go. We're negative here and we're negative here. So to the left of 3, right? And to the right of 7. So like Emiliano said, our answers would be negative infinity to 3. And this time is going to be a bracket. Why is it a bracket? No, it's not a bracket. Set us all up for failure. It's a vertical asymptote. Can't be a bracket. Silly guys. I tricked you. But at our x-intercept, we can be. So at 7, we do have a bracket and it goes to infinity. So that would be my solution set. All right, on the one that I asked you to do as you're due now, everything was already done for you. It was already by itself. Everything was fully factored. You just have to go through and create your sign chart. So creating your sign chart, remember that means identify your x-intercepts and identify your vertical asymptotes. Okay. So our x-intercepts come from the numerator by taking our numerator and setting it equal to 0. Those factors equal to 0, right? So if we have x minus 3 equals 0, and we have x plus 2 equals 0, what are our x-intercepts? Our x-intercepts are at 3 and negative 2. That's my brace. I know, it's glorious. Yes, you set the numerator factors equal to 0. All right. Next, after we find our zeros, we're now going to find our vertical asymptotes. How do you find your vertical asymptotes? Find vertical asymptotes, we set our denominator factors equal to 0. What's our denominator factor? X minus 2 equal to 0. So therefore, our vertical asymptote set x equals what? 2. All right. So these are our key points for our sign chart. So I'm going to create my sign chart. That is a horrible. That's I can't even pretend that's straight. I can't even tell you to pretend. Let's try that again. I'm gonna concentrate real hard. Yeah, there you go. Shh, it's better than the first. All right, so important values go in. We have -2. -2 is a x-intercept. We have +2. +2 is a vertical asymptote. And we have +3, and +3 is a x-intercept. Agree? Agree. All right, now that I've created my sign charts, now it comes to me testing the values to the left and to the right of these points, to these values. So up first, what should I test? You want to do -4? -3. All right, so again, all we care about are the signs, nothing else. So I'm just going to ask about the signs. So if I plug in -3, -3, that's going to give me a negative, right? -3 plus 2 squared is going to give me a positive, okay? -3 minus 2 is going to give me a negative. So I have a negative, negatives, a negative and a negative makes a. So all of this is going to be positive. We're not looking at the values. We're just paying attention to the signs. Got it? All right. Between -2 and 2, we're going to do what? 0, baby. 0. All right. 0 minus 3, negative or positive? 0 plus 2 squared, negative or positive? 0 minus 2. What do I have again? Negative, negatives make positive. So this is going to be +2. All right. Between 2 and 3, we are going to use 2. All we got is 2.5. I don't know. 2.5 minus 3, negative or positive? 2.5 minus 3. 2.5 plus 2 squared. Okay. Then we have 2.5 minus 2. Positive. Oh no, this is going to be a negative. We don't have a negative times a negative or a negative divided by a negative, right? All right. 4. On 4, we plug in 4. 4 minus 3 is going to give us a. 4 plus 2 squared is going to give us a. And then 4 minus 2 is going to give us a. So this is going to be positive. So I'm asking, when is the graph, what am I looking for? Greater than 0. So I need to know where all my positives are. Well, we're highlighting so we can write the intervals. We wrote it right here.
Wait, the intervals.
The intervals where we're positive at?
Okay, yeah.
All right, so notice that this is all continuously positive, right? So I can just say from 2 and beyond. Does that make sense? Do I have to write it as 2 separate intervals? No, I don't. And I'm not going to. Because everything to the left is positive. Everything to the left of 2 is positive. Instead of me writing 2 separate intervals, I can just write 1 interval from negative infinity all the way up until 2. Does that make sense?
And it's stuff that you look at the different you keep going, it's positive.
Yeah. Mm-hmm. So we have negative infinity to 2, and these are both parentheses because, like Alana just said, 2 is a vertical asymptote. And then we become positive again from 3. 3 is a x-intercept, so it's a bracket. So 3 to positive infinity. And that would be our solution. How did you do on your do now? Okay.
I think it makes sense.
Good job. All right. So again, step 1, numerator equal to 0, and you're going to find your x-intercepts. Step 2, denominator equal to 0, and you're going to find your vertical asymptotes. Step 3, as you plot numerically in numerical order, you make a line with those values. 4, you find values, plug them in, and you evaluate their signs. How are the signs changing? Sign chart. All right. Seeing how we've only learned 1 unit of the AP test, I don't think you are. We have 2 more units to go. 2 more whole units. Well, the units are broken down in parts. Like we're in unit 1 right now, and there's 1A and 1B, right? And 1C. So I got it. Yeah. Okay. I'm good. All right, cool. All right. Just making sure that we're good graphically. Because sometimes when we learn things, we then forget how to do things the original way. All right. So on the graph, here we have h of x. So the function h of x is listed. If I ask you when h of x is less than or equal to 0, what are you looking for? If I'm looking for when it's less than 0, I'm looking for when it's what? Negative. So below the x-axis, right? So when is this function below the x-axis?
The upside down view.
Parabola. Do we see that? Okay. So when we write it out, where does it start? -3. It starts at the asymptote. Remember, it's all defined by your x's. And when does it end? Your asymptote is at -3. And it goes up to -1. And then the other piece is from +1. Yep. Yep, it's coming. Thank you. Not positive, but yes, included. Okay. Then where's the other piece? 2. And it goes towards, no, 3. Remember, x-axis, you're not stupid at all.
Really?
Oh, okay. Just gonna ignore him. All right. Yeah, it's a bracket. All right. B is an example of when it's asked you to analyze values other than 0. In this case, we can't subtract it, so we actually use the graph to analyze. So we're looking at now, instead of looking at below 2 and below 0, we're now analyzing at 2. And if I'm greater than or equal to 2, I'm looking for when it is what at 2? It's above the 2. So when is it above y equals 2? So here's y equals 2. When is my graph above y equals 2? A lot of the time, right? A lot of the time we're above. We have here from -infinity all the way up until to -3. And then from 3 to infinity. You're right, 3 to infinity. All right, so we have from -infinity up until we hit our asymptote, which is at -3. Well, yeah.
So if the graph is like this, like the guy on the left side,
Uh-huh.
you're always talking to the asymptote.
Yes. That's because it says y. When am I, it gives me a value other than 0, right? So I'm looking at above 2. When is it above 2? Well, I'm above 2. From here, where else am I above 2? What's my last piece? 3 to infinity. Agree? All right. And then last, it says, when is h of x greater than 0? So when we're looking for when it's above 0 now. So when is it above 0? So it's here and we got to include this little piece. You see that guy? So now we have from -infinity to -3. And we have from -1 to +2 and 3 to infinity. Do we see the difference between B and C?
You have more than you can have a lot of these.
You can have, yes, you can have more than one U. Yes. Oh, thank you. Good call, Emiliano. This should just be parentheses because it says strictly greater than, not equal to. Thank you. All right.